Welcome, guys. So we've got like 112 slides to get
No,
through
we
in the
don't.
next. No.
45 minutes. You promised me 45 minutes.
Can we hit 46? Okay. Yeah. Thank you. No, we'll have some fun today. Do you have a Z at home?
I have two actually.
You have two?
Yeah.
In the
two
office,
Zs?
not in the garage, right?
I beg your pardon?
Do you have them in your office or in your garage at home?
My bedroom.
Okay.
In your bedroom.
Keeps it warm. Good
Live
white
in the Alps,
noise.
It's cold, so we can need some heat.
My floor is
Yeah.
and not pretty noisy at all.
Yeah.
You have either Z or like a crypto thing that's just turning it.
Yeah.
It'll put out the 8.
Yep. Very cool. No, this is going to be a fun conversation. Hopefully, we got a few more people. Because the cool thing is, while we built this on Z, it really applies to anything SLES. So actually, truthfully, are you running Z?
Definitely not.
Okay.
Yeah.
How many Linux systems?
I work for Amazon.
Work for what? Okay.
Oh, okay.
So just a couple. Yeah. Some ARM,
Handful.
some x86.
I think we work 50 years for IBM.
Okay.
We put it in, then some CVM, all the
Very cool. So this will feel like home.
But I'm not really here because of Z. I'm more here for the
Yeah.
Yeah.
Well, and
Yeah,
that's
they're fun.
where I was headed with this. Is this truly is applicable across? Because it's Linux. We just happened to be working with a group that ran into this issue on their Z and their ZVMs. And they kept getting called into the principal's office going, your crap's not working. And so we're going to have some fun talking about that solution. Are you using a mainframe?
No, but at university I did take a couple courses on it.
Nice.
I'm familiar enough.
But like I said, this is just going to be straight up Linux. And then Kurt's run everything. Exactly. More so, he knows the people to go take care of everything.
other people that could take care of it. 2 of them are right here.
Yeah.
I rarely have to go past that one.
Him. No.
No,
Kurt is actually
boss's boss.
he's in charge of SUSE services
Yeah.
for North America, North and South America. So he's Roberto's boss,
His
a
boss.
couple of levels up.
Yeah. 3 level, full of 3 level.
Oh, yeah, for sure. We have a bunch of guys assigned to your account.
Yeah.
It is a good thing.
It's not your fault. He didn't do it.
No, but
I rarely get any escalations about Amazon, so he's doing something.
is that James?
Yeah, James' team.
Okay.
Yeah.
Wow.
I'm not very bossy, but he does report me.
Yeah.
James Sampson, right? Yeah, exactly.
If you ever want someone to manage you, Kurt's the guy to do it.
No, actually, I love working with Kurt. We've interacted on a number of common customers.
I try to stay out of their way. My philosophy is you give them a piece of rope, and they can either hang themselves or climb to the top.
Yeah.
They can choose. That's
Yeah.
what I'm not gonna walk.
So we'll give it, since we just got 2 of you. If we got 2 of you, we're still delivering. We're still going to deliver the session. We'll still have some fun. But hopefully, huh?
School's not canceled.
School is not canceled.
Not canceled.
No snow day. We're in Florida. We're not doing snow days down here, Kurt. Come on. This is not Utah. Okay, you cannot sit in the back row. Dude, come on. I'm going to make him move next. Yeah,
You can?
right here next to the projector, so you're dead on with the screen. No, welcome. We'll give it another couple minutes. Yeah, let's kill one door. Thank you.
Yeah, I'm only showing 1 minute over.
Yeah. Okay. Since there's so few of us, when we go do introductions, you guys get to introduce yourselves too. So, Craig Little, I'm one of the solution architects for North America.
Roberto Angelino, I'm the premium support engineer.
So we have been working with this particular customer on some resource utilization issues. So we've got an agenda. We're going to do some introductions, some customer profile. We're going to talk about the solution component, how we help them solve getting called into the principal's office, as it were. And we're going to go into some pretty deep detail of how C Group's resource management pieces are working. Okay, introduction. Again, strategic solutions architect. So I get to do the pre-sale side of interacting with a whole bunch of cool customers. So it's a lot of fun. Because the strategic side, I get to do all these name brands that you hear regularly and go talk with them. But I've got my coworker here who's on a lot of the same accounts on the premium services side. Go ahead, Roberto.
Yeah, I'm the premium support engineer. I mean, I've been doing it for a while, so it's fun. You get different problems from different customers.
And so what we're going to talk about is one of those very problems. The customer hit us on a cadence call. He's going, guys, this is what I'm running into. But before we get there, we're going to start here. And if I could have you introduce yourself. Yeah. And let me know if you've got a Z mainframe running in your data center, in your garage, your bedroom.
Yeah. Felix worked for Amazon, AWS. The team that I worked for, I've been a system developing engineer. He's there for all 8 years now. I work really close with SAP. So my thing.
You got some big systems.
Yeah.
Oh, okay.
Mostly related to SAP, but I've been, doing little doing stuff for that. So I come from a Linux background. I don't come from an SAP side. So I can see groups in the past and all that. So that's why I love this thing.
Excellent. We get to get really nerdy today. Kurt?
I'm Kurt Miller. I've been with Novell/SUSE. We bought it for 27 years. So just getting started. Love it. And I run the service organization for North and South America. And I have 2 questions for you guys.
Yes.
First one was the last time you cut your beard. Like, when did you not have a beard?
Oh.
When was the last time you had it?
When I started dating my wife back in '88. Yeah.
So,
And then it went.
Was it because of her? Because I'm going to keep that in the vault.
She says no. She says it's genes, but I beg to differ.
so I started the goatee about 92 because I had a very baby face.
And you've had it ever since?
Now, it used to be more very tight trimmed. I let it go long about 9 years ago, 10 years ago. And I cut it about every 3 or 4 months. Take a couple inches off. So, perfect. Thank you, Kurt. Go ahead and introduce yourself.
So I'm Tyler. I'm actually a branch or support engineer, just kind of in the general pool there. And the C Group stuff is old news to me, so I'm just curious.
Excellent. Excellent. We'll have some fun. So no Z mainframes running around in your garage. Okay. Perfect.
I'm Harry. I'm a SUSE partner.
Excellent.
So we work closely with SUSE in helping some of your customers achieve some of their sort of real mission critical high availability.
Oh, okay. This is
Particularly
perfect.
around sort of custom apps. and
Yeah.
things like that.
This
Okay.
is perfect.
Very cool.
Science technology.
Excellent. Welcome. Like I said, we're gonna have some fun.
I used to work for the lab as well. I just want to play.
Plate spin. Yeah, I remember plate spin.
Okay. I'm gonna take a quick time out. So you work for PlateSpin. Now, does your current solution set similar to the PlateSpin migrate?
No.
Okay.
This is something completely.
Something completely different. What did you do for PlateSpin?
So I was the Dell accountant.
Okay.
Oh.
So I come from a pre-sales background, but that was the first time I turned to the dark side and started doing sales.
Okay. Because at that point, I was on Novell Consulting,
Right.
and we actually used PlateSpin Migrate to move Dick's Sporting Goods' entire data center live over the course of 3 weeks, 3 weekends. We'd pre-migrate, and then we'd cut them live, and systems were down half an hour, 45 minutes. And they got a major performance boost because we took them off old crusty hardware and put them on brand new Lenovo hardware in that migration process. Didn't lift a single machine in that migration. Spectacular. It was some cool stuff. Sorry, we had to digress there for a minute. Okay, you're coming in during introductions. Since you're late, you have to sit right here. Do move forward just a little bit. But if you would introduce yourself, please. Since we only have a few people, we're having everybody introduce themselves. Just a little company. You make some hardware that everybody uses to talk on. Excellent. Now, do you have a Z mainframe running around? Excellent. But you know what C groups are and are interested. Wonderful. Okay, I think we got all the introductions out. So Roberto and I support, or I do the pre-sales, he's doing the premium support, a large financial institution banking, think banking. Nationwide presence, North America, they have a number of Z mainframes. So this solution set really isn't dictated that it has to be on Z, but that's where we ran into the issues. Welcome. And they've been using Linux forever. You know, when they brought the Zs in, they put Linux on them, and I think it's a WebSphere application that's currently running on these Zs, and it started forever ago, but it's core banking applications. So this is stuff that's critical to their business, and they hit us with a question. The question is, I am getting performance slowdowns. But the large number of Z workloads, I was kind of a little ahead of my slides apparently. They use SUSE Manager or SUSE Multi-Linux Manager. So a good example, do you know the number of managed VMs or workloads?
I don't, it's hundreds.
15, yeah, I thought it was like 1,500 to 2,000.
Yeah, I don't remember.
It's a decent amount of ZVMs that they're managing with SUSE Manager. They've got, like everybody, a bunch of IT agents. So they've got, I don't know if they're using CrowdStrike, but whatever, all of those backup agents and all these other sorts of things running in addition to the core business software. Application owners were calling these guys and going, hey, I'm getting slowdown. Your servers aren't running fast enough. And as they were digging into it, they were finding that it was the infrastructure agents. And I don't know how many of you have to work with systems that have been dictated by security and other folks to have all this other crap running on it and getting in the way of the processes. Okay? And so that's exactly what we were running into here. So the customer hit us with this periodic slowdowns issue. They're going, okay guys, because we do a monthly cadence. So we're constantly chatting with them. He gets calls going, hey, I got this question on SUSE Manager. Can you open a ticket for me? These sorts of conversations. So they bring this information to us. Periodic slowdowns. The slowdowns appear to be coming from the IT agents. Business users are seeing the impacts. And they're relating it to cost, because this is core business applications. People are swiping credit cards, and that transaction's not getting done fast enough. The SLAs are not being met. This is where this team's getting called into the principal's office going, you're not doing what you're supposed to do. And then the uncomfortable meetings due to those SLAs not being met. The pattern that we were running into is CPU utilization. Things were spiking the CPU utilization, not allowing those core business applications to run in an appropriate time frame. So that's what they hit us with. Roberto goes, hey, let's look at doing something like this. And so we started digging in during one of these cadence calls on potential solutions. My favorite is bullet number 2. Get that extra crap off the system.
Can't do it.
Can't do it. Can't do it at all. Scale wider. That was another one of my favorites. Being on the sales side of things, yeah, buy a new Z and buy a whole bunch of new subscriptions from us. You know, double thumbs up for me on that one. They didn't take that one either. Then we started digging into resource allocation pieces. It's like, okay, finally, if you're not going to spend money, we can write some code and take care of this a different way. From an approach perspective, so we're system group, CD, some third-party things, but from approach perspective, it's how do we start to limit those resource pieces? Do I want to limit it for all processes? What were some of the other thoughts that you had when we first started with these issues on the approach?
Yeah, so they originally approached us with these three areas, these three groups of control groups. One was like the business critical apps. Then they had like a second tier, and then they had infrastructure. And so we kept talking to them about it, and they were like asking questions like, should we include kernel threads in should we like lock them down? And I'm like, no, don't touch the kernel threads unless you want your VMs to not work. So we had, it was back and forth a discussion with them. Finally, I'm thinking, well, we don't want to touch the business critical apps because then the business owners will start yelling at us because we recommended to them that they do this a certain way, and we're like, no, I don't want to do. We shouldn't do that. So the issue here is something is running that is affecting them, and they shouldn't be running as often as they should because it's stealing CPU. Well, not stealing, but these processes don't know. They just get CPU time and they just use as much as they can.
I'm going to interject here for just a second. One of the things that's very different looking at Linux on a mainframe versus Linux on a lot of other platforms, mainframes have such a structure from a tooling perspective and understanding of, hey, that process you just spawned used 5 extra cycles than it should have. They are able to measure and look at utilization at that kind of level. They're used to doing it for 30 or 40 years. So they really understand it at that detail of a level. And so these guys are going, this is wrong. This shouldn't be running in this fashion. So I like the approach where it's like, let's not touch the other stuff. Let's go take this other group of apps where we're not going to get yelled at if we do something wrong, kind of thing. And so I like your less risk.
Yeah, so we basically, the approach that I took, I always take, that's just the way I think is you want the path of least resistance. So you want to touch the things that they're saying are consuming more CPU sources than they would like them to. So, and obviously it's less risk. Right. So that's the approach that I took.
So that brings us to our overall solution set here. And I'm actually going to hand the slide mover over to Roberto here.
Okay, so does this have a pointer? Is that? No.
No.
Okay. Anyway, so originally they basically came to us and saying, hey, we want to use C groups. And literally, like, you would have to touch /sysfs C group directory, which has every process, and every process has statistics about how much CPU usage they have, what the quota is, stuff like that. It's got a lot more than that, but it's got a lot of stuff. So, and they want to fine-tune control, only keep track of processes that are in the resource control group. We don't want to touch the processes that they really need to run unrestricted. And don't track non-resource control group processes because it's just too much overhead. So let me step back a little bit. So this is like one solution, right? The solution, and that solution involves like writing a script, either Bash, Python, whatever language you want to use, to actually look at the processes that you're trying to manage, and then making sure that they're not consuming too much, and then when they are, just to back them off. I find that it was a little bit too risky, and also we didn't know what their skill set was with respect to are they okay with doing a Python or a Bash? Because I actually started doing this in Bash, and 50 lines into it, I'm like, yeah, this is the wrong scripting language to use for this. So I kept looking. Then there's other things like the cost of implementation. Let's say you do write this in Python or whatever language that you like to use. Then you got to look at maintenance because then it becomes a living thing where you have to maintain it, you have to fix it if there's issues with it, etc. And then you have to monitor and manage processes in the C group directory, and it has to work pretty fast, and it has to have little overhead. Okay, so then the second thing I looked at was using systemd. So systemd leverages C groups, so there's no scripting involved. Now, let me take a step back here. So there's two pieces to this, right? There's the piece where they want to limit these processes to not consume, whatever they define as a percentage of what they think they should use. Then there's the other piece is, you don't know if that's going to work unless you measure it. So the other piece that measures it, you have to look at, you don't have to, you could use OS provided tools like ACCT, for example, for process accounting. So you can, because you need to know, like, okay, these things are not consuming as many CPU cycles as they were before and after, and then compare and say, is what we did working? So that's just keep that in the back of your mind, because later on we're gonna see why that's important. So anyway, only want to keep track of processes that are attached to system D services. Most of what they're running, these infrastructure apps, have a service associated with it. It's less overhead. It takes advantage of System D, which has been around for about 15 years. It's pretty well known. So the environment is actually two different versions of SLES. SLES 12 SP5, that's running System D 228, and SLES 15 SP6, which is System D 254. And the reason why I call this out is you'll see later why. Because the implementation, we had to make sure whatever we asked the customer to try to do, that it worked in both. And it didn't, and I had to overcome that obstacle, and we'll show you what
because this customer has a portion of their estate still running 12 SP5, so they're actually running the long-term support repos for that one, and they've got a lot of it that's current. Yeah, but they've got a split between those two.
The SLES 12, the reason why they haven't gotten off of it is because that's running a lot of the core business mission critical applications, and they're in the process of supporting those to SLES 15. Eventually, SLES 12 is going to go away. So the implementation was to utilize System D override capabilities, and it's incredibly easy. But you don't know that until you actually go through try different things, right?
But like easy, little overhead, less risk,
and it's well documented.
Yep. Now that's an important step right there,
so,
or important component.
So I just want to call out again that the least common denominator here is SLES 12 SP5. It has to work in SLES 12 SP5 as well as SLES 15 is not the problem, because it's a much more, it's a newer version. It's got a lot more features than SLES 12 SP5. All right, so this, we're using an example of 3 typical infrastructure services: a backup, for example, scanner, which is like a security scanner, net logger, right? That's something that's on pretty much every server. There may be more services, but for the reason of this example, this is what I decided to test with. So, and the way we're doing is basically one slice to rule them all. We have this slice called infra apps, and we're limiting CPU resources to 5% utilization. Now, why 5%? Well, that's just the number that I picked. Originally, I think the customer wanted to do 25%. And so this is configurable. So, and the slice looks like this. You see on the right there, the little box, infra apps that slice. No, it is not it's not like a systemd service that shows up in etc systemd/system, okay? It's just an override, okay? So you basically, the override is the file called 50-cpuquota.com. And really, that's all you need to do is you basically, oh, you know what? That slice needs to be, sorry, there's a little formatting issue. That slice needs to have its own line above CPU quota, okay?
Oh.
So, sorry about that. I thought
yeah, I might have done that in some of my formatting.
Oh, okay.
Sorry.
Sorry. All right, so I'm just going to go through the services real quick. If you guys have any questions, just stop me.
Yeah, absolutely. Interrupt.
So we're going to go on I'm going to start on the left here. Basically, this is a System 5 service that got turned into a System D service. You can see the exec start is basically calling out some script in /etc unit.d to start and stop. And all that does, all 3 of these services run DD. That's just to show what, I just needed some command to take a lot of CPU cycles. That's all that does. So the backup service has 2 files. It's got a slice, which basically binds it to the infra slice that's slice. Okay, so you need that for whatever service you're going to be trying to control. The quota for this slice you really don't need, but I put it in here just as an example, and that quota is set for backup service is set to 20%. Okay? Any questions? Everything's pretty clear? Yeah. What?
Is 20% of the 5%?
No. Yeah. I'll answer that in 3 slides. Okay. 3
But
slides.
good question.
Yeah. You're going to see a before and after picture.
Because there's a 15% on this page.
Yeah, so this is the S scanner, security scanners. I don't know if you looked at the exec start. This is a straight systemd service. And again, that's a DD command. If you ever want to, if you want to peg CPU, just run that. It also has the infraslice configuration, binding it to the infraslice, and it's got the CPU code, and that's a 15%. And then the last one is the net logger. Again, it's running DD. This doesn't have a CPU code. It's basically, it's going to run as fast as possible, okay?
So
any questions?
I'm gonna throw a quick question. These 3 examples are your test cases that you're
Yes.
running in your lab.
Right.
These are not what the customer was
Right,
running
no,
into.
the customer's not running DD as a net.
Yeah. But I want to make sure and clarify.
Yeah.
I was just gonna say, I know these guys. I think they might.
I don't know if they would do that. They're probably the application users will probably get not happy about it. Anyway, so this is before and after. Now, before is without the infraslice. This is like no overrides, no slice override in those directories for each of those services. Okay. So before you see the top 93%, that's the net logger because that doesn't have a quota. The 20% is, I think, the backup. And the S scanner is the 15%, or is vice versa. Anyway,
Or
it doesn't
13,
matter.
yeah.
And this is after binding all 3 services to the infra app slice. Notice we're down to 5% because that's what we configured as that slice can only use that. Okay?
So you took it down to 5% total for
Right.
the slice.
Right. And you know when stuff runs, like if you're doing a backup, it's doing I/O, it's not going to take like as much. It may not take as much CPU. It's going to be like it's not consistently 2%, right? If you just run top all the time, they'll change. Sometimes it'll be 1, sometimes it'll be 0. It just depends on what's going on. All right, so back to the least common denominator. When we ran this configuration on SLES 12, it didn't work, okay? Because SLES 15 automatically turns on CPU quota. Okay, now why is that important? Remember I said we need to measure, right? We need to measure the processes. Well, in order for us to measure, systemd has to tell C groups, hey, put these processes, turn on CPU quota. Okay, for SLES 15, it's off the bat. You don't need to explicitly set it.
It's a default setting out of the
Right.
box.
And so when in SLES 15, when CPU quota is turned on, systemd automatically turns on CPU quota, CPU accounting. Sorry, and you'll see like the infra app that slice, and then basically all the surfaces that are part of that slice. And then if you see they're in further, then you could look at the CPU.max, CPU quota, just to see if you start measuring, if you start collecting that data, like how much CPU that process is taking, or service is taking, then you start collecting it and put it in a database or shipping it off to someplace. So that's why we need that. So this requirement is specifically so for the measuring part of it, right? So this is the part where we're just limiting the services to a specific resource limit.
Can I throw a restate here to make
Sure.
sure I've got it correct? The quota pieces are necessary to give the metric so it knows how much to carve or to drop down.
Right.
For the slice to be able to work.
Right.
So you have to have a measurement so it knows what it needs to go do.
So it doesn't matter what the reason why I put the quota in those 2 services is just to show that, because if I didn't, all 3 run at 100%. I just wanted to show that those aren't really needed for the service, because once you attach them to the slice overrides it, okay? You guys understand? Mm-hmm. Good, okay. Okay,
Correct.
so again, least common denominators. Now, for SLES 12 SP5, on systemd 228 will not turn on CPU counting without explicitly setting it. Okay, so you actually have to add an override called 50, CPU count. And all that's doing is, see the example on the bottom where it says CPU count equals true? You have to explicitly set it. So rather than, I suggested to the customer, rather than keep two different versions of the config files, right? One for /15, one for /12, just use this version, because when you're done with /12, you can just use, you still continue to use it and then get rid of the CPU counter. You just keep your configuration to a minimal state. Okay, that's all
So
that.
adding the extra pieces didn't cause any issues?
No, not for
So you might as well
/15,
just leave
yeah.
it, so everything is handled in the same fashion?
Having CPU accounting, this was actually the last issue we had with the customer, because we were like, hey, we're not seeing, we can't measure the /12 services without them being showing up in /sysfs C group /CPU ACTT, okay, on /12. You guys follow? Okay. So, want to measure results, okay? When you measure results, you can't start measuring once you implement your solution. You got to start measuring. You got to measure beforehand. You got to set up a baseline, and it needs to be a good baseline. So before you even start limiting your processes, you need to measure. So you need that piece that is saying it's messy, where you're basically capturing the CPU max values in time over a period of time and saving them, and so you can basically plot them and chart them before, enough to show a pattern, okay?
And did our customer do that?
We're getting to that.
Yeah.
Yeah, we're getting to that. So,
Yeah.
yeah. So you want to collect data after you're limiting the resources. After you bind them to this infra app slice, then you want to collect the same data, okay? Same time frame is baseline. Basically, I'm saying if you collect data prior for a month or a week, do the same thing for after you bind them to the infra app slice. So that's what they're saying.
Yeah, because
yeah.
keep in mind, even these core banking applications, there's times of the month they're busier
Right.
than others, things of that nature. So you want to make sure you're understanding that pattern.
Right. So then you want to compare both sets and stuff, and see if you want to validate whether or not your limited CPU resources helps the business critical apps. If not, then you decrease the CPU quota, right? If let's say they set it to 25%, and it's like, yeah, it's not helping. Set it to 10%. By the way, I don't know what they set it to, but I was just.
The next cadence call, we need to ask that question. Because I'm curious now what they ended up setting it to.
All right, so the impacts, the results. So the customer has not had that piece, because remember I told you the case about the /12? They sent me a case about /12 not having CPU quota data because CPU accounting wasn't set. So they're not there yet. So they haven't implemented that yet.
But they have implemented on some of their systems.
Yes, they've done it for /15.
Right.
But I don't know if they're capturing it yet. Because if you do for /15, you'll be able to do it /12, except /12 has a little bit different data structure for C groups. Anyway, so the other thing they asked is whether they could resource limit users. Okay, so they wanted to be able to do with infra apps like infra users, like they did with services. Unfortunately, systemd, even the current version of systemd, will not allow you to do that. So the workaround is they have to limit each user. And when I talked to the engineer who was working on this, he was saying that that's how he has to do it.
They're going to head down the road of,
Oh, yeah.
here's
Yeah,
my
because-
short list of users, because there's not that many of them,
Well,
I'm
it's
assuming.
basically anybody with everybody who's access to the system who can get root access. They're afraid that somebody can go in there, accidentally run, maybe they're
Do a DD command.
They forget they're on a production machine and they're thinking they're on a dev machine. All of a sudden they run some command and this thing is taking up a lot of CPU utilization. That's why they're trying to limit users. So they're getting really clinical about not affecting these big mission critical applications, because it's they have stand-up meetings when they don't meet SLA. So this is what they decided.
Have they gone very far down the road of limiting it on the user basis?
Yeah.
Okay.
He says he's done it. but I don't know if he's done all of them. But
Well, it's probably a nice short list of users. Here's the 15 users that we need to lock down.
He's catted is the password file on some of these, and it's not short.
Yeah.
Yeah. So then the next steps, obviously, system E and C groups, you can limit I/O, you can limit memory as well. So,
But in my mind, there's a point of limiting or of diminishing returns. Because now I'm getting really kind of specific, and I might actually shoot myself in the foot.
yeah.
And so if we're achieving, I might let it run and just hang there without having to get so specific that I'm tying up or locking down memory or locking down I/O.
Even if I/O or memory is something that they do, in my mind, they're going to do that if they have a problem with it, like they did with CPU utilization.
Right.
CPU utilization was the biggest pain point, and that's what we addressed.
Yep. And so, because one of the things during cadence calls, we're going, hey, have you implemented? Is it working? And they go, well, we didn't turn on the measuring, so we don't really know what we're at. But he goes, this was a direct quote, we haven't had any stand-up meetings lately. So that's that non-empirical, I think it's working kind of thing. And it ended up, after all the machinations, all the rabbit holes and side quests that we did at the beginning of this, we ended up with a relatively simple, straightforward configuration that's easy to manage,
And reproducible.
not very risky, easy to manage, easy to deploy. We didn't even have to pull in Multi-Linux Manager to lay a config out on these systems. We could have, but it's a good, no, you're fine. Leave it here.
Is that it?
Yeah. Where to go? Call him. That's what I do. That's what Kurt does. Roberto, come fix this. It does. But truthfully, if you guys are managing, I'm not sure any of you are really at a point where you've got a whole set of systems that you're managing yourself. But I will put in a plug for that premium support engineer service. It's spectacular. Because you get a guy like Roberto that's deep in understanding of the systems that he's there to help manage. So there's some awesomeness there. And then we've got all the links to the documentation. One of the key elements to this solution that you called out, it's well documented.
Yep.
Because I've implemented some solutions where I'm going,
It's
damn, I'm
actually-
the only guy that knows how to do this, and this is not good.
It's actually over-documented,
Yeah,
but which is good. It's always good.
it is good.
I mean, I did have to look at one point, I had to look at systemd, like source code to track something
Dude,
down.
that's not that documented.
Well,
then.
what's cool?
No.
No, what's cool is that like the CPU quota, systemd resource, variable direct control, is actually maps to CPU UFS quota _US. So that again, remember at the beginning I said systemd leverages C groups, and that's the connection. They've done that mapping. SLS 15 has a lot more mappings for C groups than SLS 12. So one thing I want to mention about C groups, C groups version 1, okay, which is the default. Systemd actually uses version 1 and version 2 when it comes up. There are some apps. So the way it works is, the infra slice. If you look at the infra slice, it'll have like a tasks file in there, and it'll have the process IDs of the services that it's controlling. And that's how it knows to limit. That's how systemd knows to limit those. Okay. Some like really smart apps, if they know that they're like applications, if they know they're running on version 1, because they can check, it's really easy, they can actually move the process ID out of that group to try to get more CPU, okay? In version 2, you can't do that. So just be aware that if you deploy this and all of a sudden you see a service that was in there and it's no longer being tied to, let's say, 5%, it's taking up 100, obviously check your configuration. Make sure whenever you do anything with systemd, you do a systemd reload. Always do a systemd daemon reload, always. Also, if you have these services running and you implement the overrides and you do a system CTL, system D reload, don't expect them to be attached to the infrastructure. You got to stop them and start them again after you implement the overrides and you run system D reload, daemon reload. Okay, it's very important. Yeah, that's it. So if you want apps that are misbehaving like that, it's kind of sneaky, then you can actually boot. Okay, there's a kernel command option that basically says, hey, systemd, I want you to only use cgroups version 2, and it will do that. And that's how you get around those apps that can get around your slice that's controlling all those services.
I think that's it, man.
Yeah. Any questions?
Okay. Yeah, we can throw down the applause. Thanks.
So it is, I did not pay attention to your policy, but it's 5% of all CPUs or 5% of?
5% of all CPUs.
Okay.
Yeah.
Okay. Can you find a specific CPU?
Yes, you can.
Okay.
CPU, you can do CPU affinity. I did not do that.
Okay.
You can do, like, originally, like when I started looking into this, first thing I did, I queried engineering. It was an engineer that said, hey, use CPU weight. And I tried CPU weight. I could not get it to work. Where you're like, you have 3 applications, and like, out of those 3, maybe like security scanner is more important, so you weight it higher, right? So, and maybe backup is lower, and NetLogger is even lower than that, right? So you have these different weights. I could not get that to work. And then there's CPU affinity. So systemd has that. You don't have to do it. You have to do it with the hard code it with the file. Yeah. So it's really nice that way. But I did not touch that. I didn't because that wasn't part of the ask, right? If they decide to do that later, then they can either work on it themselves, or they can ask us about it, and then I can look into that.
Yeah. Then besides C groups, and we will lay in other alternative solutions.
Yes.
Are the customers using C groups in mind?
The customer recommended C groups in mind. They were trying to use NICE, and they were disenfranchised. NICE wasn't doing what they wanted it to do, which is fine. There's also a lib cgroups-tools package, but that package got removed in SLES 12 SP4, which means it wasn't available in SLES 12 SP5 or obviously in SLES 15. So I looked at that briefly, and it's a nice little package, but it's not viable for their environment. Basically, there's commercial tools that you can use, like Tivoli, but if the customer wanted to use that, they wouldn't have come to us with a, hey, can you help us do this?
Yeah.
But no, that's pretty much what we looked at.
But when they came with that C groups, it was, hey, would this work? More than this is what we want to do. So it was, they had an idea and then brought it to the team here to go, hey, this is what we're running into. We thought maybe this might fly. And then Roberto went deep on it and go, here's what you need, kind of thing. Yeah, it is really clean, simple.
Yep. And that's what that was what I was striving for. I didn't want to make something too complicated for them, because then they'd have to come back to us. And I don't mind them coming back to us. I mean, that's what
I was just going to say, they're just going to call you and go, dude, it's broke again.
Yeah.
But core banking, we don't want to hear about broken apps.
You had a question, no? Somebody else had a question? No?
Yeah, I had a bit of a question.
Yeah.
Since you mentioned it a little bit, what is the main difference between cgroups v1 and v2?
Okay, so cgroups v2, when I was reading up on this, cgroups v2 was specifically created for containers, because you didn't want like containers running and saying, hey, I think I'm in cgroup 1, let me change,
let me jump groups.
Yeah, let me jump out of whatever the hell I'm being contained in. Yeah, they didn't want that cross container.
So to further clarify that part of it, it's for LXC, so Linux containers, of which Singularity. What's the new name for Singularity? Does somebody know? I can't remember. It's got a new title, but Linux or Linux groups or Linux containers is a different approach than what we do with Podman, Kubernetes, and those containers. It really is just putting boundaries around the resources. It's not like standard Kubernetes kinds of containers. But LXC is a valid approach to carving up resources on a box.
Yeah, I did have a case that I didn't run personally, but that I was hearing from some of my colleagues where a customer was trying to go from secret V1 to V2 in a rancher environment, and we're having some issues. I don't remember exactly what it is, but I think some containers were, just having trouble with resource utilization and things like that. So.
Yeah, or maybe those containers were misbehaving. They just found out when they went straight to the V2, right? Yeah, which is what I was saying. It's like you don't know who's misbehaving until you contain them. And you're like, hey, why isn't this thing working now? Well, it's not working because of what it's. You go to the vendor and say, hey, why is this thing behaving like this?
Right. Very cool. Well, guys, thank you for your time. Hopefully you had fun. Nobody fell asleep, so I'm gonna give a little bit of credit here that we did okay. So, but again, we thank you for your time and for hanging out with us. Now, we didn't get your name. You came in just after everybody introduced themselves. So, Simon? One more time. Clever? Yes. And what organization do you work with? Sorry? What organization do you work with? Very nice. Oh. Pleasure to have you with us for our talk today. Did it make sense? Excellent. So I think later you'll be able to grab the decks and all that fun sort of stuff, and potentially recordings and all of that. But again, thank you so much, guys. I appreciate it. Have a great day. Thank you.